Hello and welcome to Django-powered mobile apps. I'm Tim Kuehlhorn, and I wanted to start by kind of talking about the scenario. Basically, you're on a team that's developing a mobile app, and you are responsible for writing the server that it talks to. It's a network-enabled mobile app, and it's going to be sending and receiving probably a lot of data, and you need to develop an infrastructure for it, and you probably don't have a lot of time. So the app could be a native mobile client, iOS, Android, etc. Could be a mobile web app, or the company could be trying to do all of the above. That's getting more and more common, actually, and platforms that aren't even listed here. So I wanted to start by outlining some API design goals. You want an API that's clear and easy to understand, makes efficient use of network requests, because mobile apps are just that, mobile. They're going all over the place. They're encountering all kinds of different network environments, and you want to respect that, and you want to give as much data. Basically, you want to give as much data as you can in a single request, as long as it fits within their bandwidth limits. And you also want to keep in mind that you're probably going to be adding features over the lifetime of this platform. So you want to have ways to extend your API and add more resources, add more sub-resources, and build out your API in an intelligent and well-crafted manner. So one of the things that I think is important is to collaborate closely with the mobile app developers throughout the process, and that begins with the mockups. So UI mockups, I think, are really useful not just for the mobile side, but also when you're designing your API, because you can tailor your requests to specifically address you could even design views that supply all the data needed to render a single screen at a time or more. And so it helps to be able to see that and foresee those needs, instead of just developing kind of a very simple, just a CRUD interface, just create, read, update, delete. However, until you start building the system, your design really is just a pile of assumptions. And sometimes they're good assumptions, but anytime you're making assumptions, there's a decently good chance that some of them will be wrong. And so to deal with that, I love prototyping. I love building test apps, building a prototype that I may throw away the next day. But what I get from those are knowledge. What I get from those is knowledge about the design constraints of my system and the tools that I'm choosing to use. When you develop the app and the API together, you have a complete picture of your platform as it evolves. I think that if you do the API first, then you're probably going to cause headaches for your app developers, and the app developers will encounter use cases and scenarios that you didn't conceive of when you were designing your API, and either you'll have to come back and do more work later anyways that will then not be part of your holistic design, or it'll compromise the functionality of the app. So to build these rapid prototypes, I like Django, and with Django, you can get started on the design right away. It's batteries included, so you're connected to a database. You can receive requests. There are users, an admin interface, which is surprisingly handy when you're dealing with a data-driven platform, and it really lends itself to iterative development. If you need to revise your models, you can do that. If you need to just create an entirely new set of classes and relationships, it's happy to oblige. And there's a lot of packages you can lean on for functionality, like SSL or in this instance, REST, because Django gives us an ORM and middleware, but it really doesn't help you communicate with the mobile app. Enter Django REST framework. It's a Django package that provides a bunch of features to help develop these kind of APIs. I'm going to focus on 3 of them in particular, but it does way more than that, and way more than I would have any hope of covering in this talk. But we'll start with serializers. Serializers translate your model data into HTTP content. So JSON, XML, YAML, And you could even write your own serializers that would serialize to any kind of data. But I'm going to focus on JSON because I think it's the most common for a mobile app. And there are some really nice libraries on the mobile side, native mobile specifically, that if you integrate well with them, it saves tons of time. You can get up and running in a very short period of time if you use something like RESTKit on iOS, or there are also several options on the Android side. But if you keep their architectures in mind when you're designing your API, then RESTKit, for instance, can give you things like data persistence, can give you a lot of can automatically parse and store individual like lists of model objects without having to write your own custom code for that. So it saves a lot of time. You can also nest your serializers to return a lot of complex data in a single request. And that's important for mobile because you don't want to be opening 50 HTTP connections just to render one screen of data. So by building those, by including the data itself, not just a URL, not just a reference, you can be very efficient with how you can strategize very, very well how you make use of your HTTP requests. So Viewsets are actually a relatively new feature from Django REST framework, and essentially it's a class-based view in Django. And if you're not familiar with a class-based view, basically you can define a class that will respond to the different like HTTP methods, so post, get, put, etc., and use different view functions for each of those methods. And so Viewsets are similar, but actually kind of expand on that. They let you define things such as I want to get a list of these objects. So I don't want just one. I want a list, or I want the details of a single object, or I want to create one, update, delete, etc. And then the Viewsets you can connect to routers, which then generate your URL structure for that resource. So you can use the same routers across different models and automatically have a consistent and well-defined URL structure, which makes for happy developers. REST Framework also gives you, oh, that's completely unreadable. Sorry about that. REST Framework also gives you a browsable API console. You can check it out on their webpage, but essentially it renders your endpoint, the structure of the response, and you can even authenticate through the console and send posts and all kinds of requests through the console to have a fully browsable active view of your API. So developers can experiment in the console to see what's going to happen and then take that expertise to the mobile app, which makes it easier and faster to develop with. The console is great, but it's no substitute for excellent documentation. And that's where I think Sphinx comes in. How many people use Sphinx? So a handful. How many people wish other people would use Sphinx more? Yeah, basically, if you don't know about Sphinx, if you've seen a lot of high-profile Python projects like Kenneth Wright's requests or Flask, or a lot of them, then their documentation is written in Sphinx and then compiled to HTML and hosted on the web. So Sphinx, you write your docs in a format called restructuredText, which is similar to Markdown if you've heard of that, and then and essentially and it makes documentation writing fun, honest. So with Sphinx, so when you're documenting a REST framework or a REST API, they have a contributed module called the HttpDomain, and it generates a great-looking reference, which you probably can't see any of, but that's okay. I've got a URL at the end of my slides that'll have references to all these things. But with HttpDomain, you can very quickly write your restructured text to describe each endpoint, its parameters, an example response, an example request, and then the status codes and what those status codes mean for the particular request. So it generates a great looking reference that your developers that the app developers can then rely on to get an understanding of what your API needs. But you shouldn't stop at just listing all your endpoints. You should also write docs that explain how to use the API. And I kind of look at that as the difference between writing a description of something and just like giving somebody a list of components and then what each component is, and then teaching somebody how to use those components to build something. And I think that, and I'm gonna paraphrase Ben Franklin here, and I'm gonna say an ounce of instruction can be worth a pound of description. And I think that giving somebody kind of a leg up, a head start, I think, or a tutorial, if you will, can engage that learning process and allow them to discover these things for themselves, and even to better understand the reference when they need to go back to that to get the details and get the specifics. You can also use your Sphinx docs like a living spec. You can make changes in your documentation ahead of your code, and then like point developers at it, point your team at it, and review those changes and kind of use it as a sketching tool. And I think that Sphinx and restructured text makes it easy to do that, and makes it it's very powerful at expressing the kind of complex ideas that you need to express when you're talking about API design. So you can make these changes, send them out, people can discuss them, and then you can kind of decide on a course of action before you even get to implementation. Because your docs are in source control, branching is easy. So even if people have differences of opinion, they could each make a branch of the docs, even edit the docs, let people review them, and then merge the approach that people think will work best. So I actually ran through those slides pretty quickly. I want to thank you all. I've got the speaker bar link will take you to the references for the Sphinx HttpDomain, Django REST framework, and I think I put Django itself, but everybody knows where that is. But I ran through a lot, and it's kind of an abstract, a bit of a high-level talk. So I definitely want to answer some questions and open the floor up. But thank you all for coming. So yeah, I think I might have overcorrected for the delay at the beginning. But did anybody have any questions about what I presented? Yes.
Have you looked at TastyPie?
Yes, I actually used TastyPie a couple years ago when for the first mobile API I wrote using Django. I used TastyPie because at the time REST framework had kind of fallen pretty far behind, and actually I think hadn't been updated in maybe a year or two. But since then, REST framework has, I think, exploded, and so when it came time to revisit that decision, I ended up going with REST framework for things like the browsable API, and I felt like the serializers and the Viewsets worked a lot better, were a lot more Django flavored, so and kind of worked better with the things that already existed. But yeah, TastyPie is excellent as well, and I may be a little behind with what they've been doing recently, but I've been really happy with REST framework so far. Yes.
Are there any either public docs that you find useful for good API documentation practices?
Not really. I mean, I think that that one thing you can do. Oh, sorry. Yeah. Let me repeat the question. So, sorry. The first question was about TastyPie versus Django REST framework. TastyPie is another API, another Django API framework add-on. But this question was: Are there public docs for how to write good REST API documentation? And my answer to that is that I don't think there's some. I haven't seen some very good specific resources for how-tos, but I find that that going to different websites with good REST APIs, looking at their documentation, you can get a lot of ideas for what helps and what doesn't. I also reference a lot of. I also look at a lot of Sphinx documentation in general and Python documentation for inspiration on what I think that other developers would want to see. And when I find that people are asking me a lot of questions like, how do you do X, how do you do this, or how do you set up this configuration, that tips me off that, okay, we need a section in the docs about that. And so like it's really great when somebody asks you a question and then you can send them a link to the specific section of the docs that explain exactly how to do it, because it saves a lot of time, and it helps reinforce the idea that the docs are your friend and are a good resource to go to find information. Yes?
In your experience so far, is it generally the case that your REST resources are your model objects? Because when I look at that, it seems a little too granular. I don't know if you
Yes.
talk about the latency stuff.
No, exactly. Yeah. So the question is, if you just tie your models directly to your serializers and your view sets, then is that too granular? And the answer is absolutely yes. It is too granular. That I touched on it a little bit, but I definitely want to expand on the idea that you can combine you can return more than one model type in a response, and so you can build these aggregate responses based on the needs of your app and kind of the needs of your clients in general, and say, okay, if I want to render a timeline or something, maybe I need a list of post model objects, user model objects, and comments or something. And by combining those in a view, much like in Django, you would write a template that would pull from all those models. You instead are writing an API view that does the same thing. That means instead of making one request to get a list of posts, one request per post in the list to get the post, one request per user in a post, et cetera, instead they all come together. Because you're using RESTKit or something, the app knows how to parse it, how to store it, and then can render its table view or whatever UI it needs to show all the data at once.
You end up writing one more like serializer to take that data point. Because I assume you can write serializers for each of the models that you have. And then
Right.
do something special.
So the question was, would you be writing kind of separate serializers for each need there? Not exactly. It's a little basically. So REST framework comes with a model serializer class that kind of does generic. You basically subclass it to create serializers for your different models, and then you don't. You can use API views and serializers together to then construct responses. So sometimes it's natural to just include other serializers in your like list serializer, and then instead of creating another one that's like list plus children, and sometimes you would create new ones as well. Sure.
You talked about RESTKit. I've heard about it. I haven't really used it. Can you talk maybe more about it or show some examples of something with it?
So the question was about RESTKit, which is an iOS REST client library, and basically RESTKit. You actually can. It's kind of similar to what you're doing on the server side, where in RESTKit you define routes, you define like serializer and deserializer mappings for particular URLs and particular JSON keys, essentially. And so in RESTKit, if everything's kind of set up in the ideal case, you can say RESTKit, get me a user with ID whatever your ID is, and RESTKit will construct the URL request, fire it off asynchronously, get the response, store it in core data and persistently, and then and notify your app that it's available. And so it can do. RESTKit is really it's really useful for that, and I think it saves a lot of developer time and makes it very very efficient to write these kind of apps. Yes.
Any advice on so when you're designing the API up front on versioning it, so in the future if you ever make a backwards compatible change, maybe you need advice on that?
Yeah, so the question is about versioning your REST API, and I've seen a lot of approaches for this. One approach is to put the version in the URL, so it'd be sort of URL/API/v1, and then you can make a v2 later on, and that's one way to do it. You can also use the HTTP content type header, so you would say like the header might be application/JSON plus my API 1.0 or something, and then and then your clients will be able to read that and decide, okay, we'll be able to send an accepts header that says, I want the 1.0 API or the 2.0 API. And I think there are a lot of different approaches, and it might depend on what your plan is for future versions and what your clients can support. Because I know it may be trickier to do some of the more complex HTTP things. So you may want to do a URL-based approach. But I don't know that I've settled on something that I think is the absolute best option. But definitely versioning is something worth thinking about when you're designing an API, because you're going to have especially with mobile apps, especially with like iOS apps, you're going to have people who have not yet updated the app, who are running on the old API, and you don't want to change your server in such a way that it breaks compatibility with the old clients that are still out there. You want to provide a clear path for upgrading. Yes?
So how do you provide protection for your RESTKit endpoint? So you've got an endpoint that the device needs to speak to independent of whether or not someone is authenticated.
Could you clarify that, please?
Sure. So let's say you need to add, before you log in with your mobile app,
Mm-hmm.
the device needs to be able to talk to your RESTful endpoint
Mm.
to get to resolve the place where you're going to do the authentication. So can you just speak to how you protect those endpoints from sort of the random person that's found your service?
Right. So the question is about how you protect your REST endpoints from like unwanted access, and that's definitely a very complicated question. Probably could be its own talk. One thing is that I feel like in general I don't think you can, if you're exposing a service like this to the public in any sense, even if you only want it to talk to your app, you have to assume that people are going to sniff packets, are going to find ways to access your endpoints without your consent, and so you need to design your system to handle that. I mean, I don't think there are steps you can take to make it more difficult, but at the end of the day, if you're sending web requests, I mean, you're going to use HTTPS regardless. You're going to use SSL, and so your traffic is going to be encrypted, but people are going to can reverse engineer things, and so you should implement your authentication such that you don't rely on sort of obscurity, I guess. But that is a very good question and an important consideration. All right. So do we have any other questions? So you're all going to write a lot of Sphinx documentation when you get back into your projects. I don't know. I use it for everything, so I really like it. Right after you write all your tests. Yeah, testing is another thing I thought about, but I realized I'm definitely not qualified to speak on testing. It's something I would like to learn more about and get better at myself. So
what's something that you learned this week in maybe preparing for the talk, or what's something you can share with us if you have some time that you learned
Sure.
this week that you're like, hey, this is awesome, and you share this?
So maybe a little bit further back than this week, but Viewsets was something actually that's relatively new to me for REST framework from when I was researching the talk, and so it seems really, it's a really cool design, I think, to be able to build all your API views in a class like Django class-based views, not just your different HTTP methods, but different use cases, and then use the router to generate the URL conf for you. And I really think that that's a good way of having like a disparate set of resources and kind of model objects, but then give them all the same interface for access, because it's easy for for discrepancies to creep in if things get implemented separately. I guess it's part of the don't repeat yourself mantra, which I'm definitely a big fan of. All right. So anything else? Okay. Thank you all for coming.